So we are going to continue in this section. Ready? So I know this is like the third day on this, and we're not even going to finish it today. There's a lot of different ways that you can, what is this section called? Building functions from functions. A lot of different ways that you can do it. Cool. Very cool. Yep, you're big kids now. You get to learn all these different things. So for example, most of the time the functions that we have dealt with have been y equals something or f of x equals something. It doesn't have to be that way. You could have the x's and the y's all mixed up together. And for those of you that are on your way to calculus land next year, that's something that we see in that class quite a bit. And so we're just going to start out doing a couple different things with this. First of all, we're going to figure out, are these ordered pairs solutions to this or not? So how do you do that? Let's plug them in, see if it works, okay? So let's start with the first one, 2, -5. So I plug the 2 in for the x. 2 squared is what?
Question. Remember what we said yesterday, if we write it down first and then we can start?
Yeah, can we pause so I can check
Can we pause?
As I was saying, so we're going to plug in the 2 for the x and the -5 for the y. So 2 squared is 4. And then we're going to multiply that by -5. Do that in a second. Plus y squared in this case would be
Y squared would be
25. Positive 25. Negative times a negative is a positive. And we need to see if that is going to equal 5 or not. So 4 times -5 is -20. Plus 25 equals 5. 5 equals 5, so this one is
correct.
correct. Yeah.
So it has a 5 in it. Does that have anything to do with it? It's coincidence.
Just a coincidence. All right, let's take a look at the next one. If you plug 1 in for x, you get 1. 1 times 3 is 3, plus 3 squared is 9. Does that equal 5? Nope, so this one is not there. Okay, and then the last one, what do you think?
No. Yes. No. No, it's 4 plus 1.
Yeah.
4 plus 1 equals 5. 2 squared is 4, times 1 is still 4, plus 1 is, good morning. What's
You
that?
put it in last year, you're good.
Oh, so I don't have to do anything?
Yeah.
Okay, sweet deal. Thanks. So this one also works. Okay?
What kind of secret code is that?
Okay, let's go old school on this. Is this thing that I put up there a function? Yes or no? Why?
Because it's a vertical line test.
Does it pass the vertical line test?
Let's graph it.
Let's graph the at least the 2 points that we know that are on it. We can't graph it yet. We're going to do that in a second, but in order to graph this, we would have to solve that for y. Okay? But we know that this point right here is on the function, or is on the graph, right? And we know this point right here is on the graph. So if I graph 2, -5, that's down here. If I graph 2, 1, that one's right there. Does it pass the vertical line test?
No.
No, because
not.
when I put in 2 one time, I got -5 as an answer. When I put in 2 another time, I got 1 as an answer. So that is not a
Falsified
function. It is a relation, not a function. Okay? Okay, so let's talk about the graphing thing. We can graph functions that look like this, and in order to do that, we have to do a little bit of algebra because we need to solve this for y first. Okay? Huh? Why is the third one in relation? No, I said this algebraic expression. This is a relation. It's not a function. but it is called a solution. Okay, no, not the individual points themselves, the whole thing. Okay, so x squared plus 2xy plus y squared equals 1. We're going to try and graph that. So in order to do that, we need to solve it for y. Okay? Now this is going to hurt just a little bit, but you can do it. Okay? Are you ready? You might say, well, let's subtract an x squared. But then what do? Subtract the 2xy, then you got a y over there, y over here. What do you subtract the y squared? None of that stuff works. And so in this case, you need to factor that. Okay?
No.
I need
Nobody
two
likes that.
things that go in the front that multiply together to give me x squared. They are x and x. I need two things in the back that multiply together to be y squared. They are y and y. Does that give me plus 2xy in the middle if I FOILed it out?
Yeah.
First times first would be x squared. If I make these pluses, if I go outside together, that's xy, right? Insides together, also xy. What's xy plus xy?
2xy.
2xy, which is what we wanted. Y times y is y squared. So this thing right here factors into x plus y times x plus y. Okay? Well, what's another way of writing x plus y times x plus y?
X plus y squared.
X plus y squared. Now, can you see a way out of the darkness?
X was just like more.
We were still trying to solve this for y.
So then x squared.
No, then we'd be back to where we started. Any bright ideas? Yeah, who said that? Nice. Square root both sides. Springs comes through, so if I square root both sides, the square root and the squared cancel, which leaves me x plus y. Be very careful with this next one. What is the square root of 1? Square root of negative 1 side. What's the square root of 1? What number times itself equals 1? Or
0.
negative 1, right. So when we take the square root of this number here, the answer is not just 1, it's plus or minus 1. Okay? Right, and then now solving this for y is easy. The last step is just to subtract x from both sides. So those cancel, and I get y equals, I'm going to put the x in front because that's what we're used to, negative x plus or minus 1. So in order to graph this, we're actually going to have to make two different functions. One is y equals negative x plus 1, and the other one is y equals negative x minus 1. Okay? So should we take a look at those graphs?
Yeah.
On our calculators? Okay, super easy. So, yep, turn those bad boys on. Get this going. Get this party started. We can start warming up.
We are.
Wow, I have a lot of batteries. Yeah, do you have batteries?
No, actually I don't. Okay, so we want negative x plus 1. Don't forget that if you're starting with a negative, you have to use this button down here, not the minus. You can't lead with the minus sign. If for some reason the calculator doesn't like that. So you're going to go negative x plus 1, and then hit enter. And then we want negative x minus 1. Okay, I'm going to go zoom 6 to make sure I have the standard viewing window going. And there is my graph. Is this a function?
It says error, but it graphs it.
No, this is definitely not a function. It fails the vertical line test all over the place, okay? So strange to think that if you start with this stuff right here, if you were to graph that, you end up getting two parallel lines. Probably didn't see that coming. How'd I do what? Make the graph? Okay, from the top. So you're here. Okay, so you're here. You get y equals. You got nothing there. So the first thing I want to graph is this one right here, negative x plus 1. Okay, so I'm going to hit the negative button, not the minus button, x plus 1. And then I'm going to go negative x minus 1. Right, and then Emily, the way you can get it back to a regular 10 by 10 window is go zoom 6, and then there you are. Okay, got it now?
My calculator broke.
Okay, good job.
That's yours.
Seriously?
Yeah. I always have
Those things that we just worked with, when the x's and the y's are all mixed up together, those are called implicit functions. Because you don't have it solved for the y. When it's y equals something, that's called an explicit function because you're explicitly told the relationship between x and y. An implicit function is when it's all mixed up together and you have to do some work to figure it out. Okay? Yeah, in order to solve for y. And you can see that when we went through this, that was a little bit awkward, right? Okay. So there's a way that we can get around that, and that's using something called parametric functions. So that's what we're going to look at now.
There you go.
And parametric functions are where you take the x and the y and you break them up into two separate things. So for example, you could say x equals t plus 1 and y equals t squared plus 2t. That's a parametric function because you have both x equals and y equals at the same time, and they're both in terms of a third variable, which is usually t. Okay? So the way that you graph these, if you wanted to do it by hand, and I won't make you do these by hand, but I'll just show you, is you would have a triple table. So you remember when you were little and you learned how to graph and you made a little XY table and we picked -2, -1, 0, 1, 2? Okay. This is the same thing, except now we're going to have a T and then an X and then a Y. Okay? And so let's do the same thing, -2, -1, 0, 1, 2. But now to figure out what X and Y are, I have to take these T's and plug them into both of these equations. Okay? So let's do the X's first because they're easy. -2 plus 1 is -1. You feeling it? Feeling the hell? We're talk about that the first week of school. All right, so you put in -2, we get -1. Put in -1, you get. Put in, hey. Put in -1, you get what? And apparently that's at least one too many. You get 0. You put in 0, you get 1, and then 2, and then 3. Okay? The y is a little bit trickier. If you put in -1, you get, well, -1 squared is,
Sorry, 4.
oh, I'm sorry, yep, you're right, I'm supposed to put in -2. So, yep, -2 squared is 4, is that, okay. And then -4 is 0, sorry. Now put in -1. 1 minus 2 is?
Wait, did you subtract 4? To add.
Well, if I put in -2 there, what do I get?
4.
4. But if I put in -2 here, what do I get?
Oh, sorry.
So that's why I ended up subtracting. Okay? So, yep, next one's going to be -1. Then after that, you get 0. And then you get
1 plus 2 is 3.
1 plus 2 is 3. And then if you plug in 2, you get, which is 8. Okay? So let's make a quick sketch of this graph, just a sloppy one. Okay? What points am I graphing? The T's, the X's, the Y's, the what's? The X and the Y's. Okay, so my first one is -1, 0, so that's going to be right around there. Then I'm at 0, -1, which is around there. And then 1, 0, 2, 1, 2, 3, and 3, 4, 5, 6, 7, 8. So what kind of a creature does it look like I have right there? It looks like I have a parabola, and then like you learned in algebra, you just because we only start at this point and went at that one, yeah, you don't just stop your graph right there. You assume it's going to continue on in both directions, okay? Is this a function?
Yes.
Yes, and so we'll go back to what Gabe said. Should we not be able to come up with an equation of this function without using t's? In fact, should you not know what it is right off the top of your head because it's one of our 10 basic functions, just shift it down 1? Does this not appear to be y equals x squared minus 1?
Yes.
Okay, so let's see if we can get that from the parametric equations. So x equals t plus 1, y equals t squared plus 2t. Gabe, take it away. What did you say? Okay, so I'm going to take this and isolate the t variable by subtracting 1 from both sides. So x minus 1 equals t, right?
Hold on.
So you can be the spokesman for the class.
So this is a parametric.
Yeah, but we're eliminating the parameter right now. Okay, now that I have that in terms of t, what I'm going to do is I'm going to take that and plug it in for the t's in there. So I'm going to rewrite the y function as, instead of being t squared, what did t equal? X minus 1, so it's going to be x minus 1 squared, plus, instead of writing the t there, 2 times t becomes 2 times x minus 1. Okay? Let's do some simplifying. What does x minus 1 squared boil out to be?
X squared. Wait, it's 1 minus 2x.
Okay, don't forget the outside-inside thing. Most of you look at this and just square the x and square the 1. That gives you this and this, but there's a middle term also. And then 2 times x is 2x, and 2 times negative 1 is negative 2. Those cancel, and as we suspected from the graph, we come up with x squared minus 1.
Okay, can we just do it this way though?
Can we what? Instead of graphing it that crazy long way? You could, or
Wait, how did you?
you could do it on your calculator, which I'm going to show you how to do.
That's
Just like
the
again.
negative.
How did I get the negative 2? I distributed the 2 to the... Oh, the negative 2x? Okay, when I go x minus 1 squared, I have to go x minus 1 times x minus 1, right? So first times first is... Okay. Okay, so Drew says, seems like a lot of work. Isn't there an easier way to do it? Oh yes. Your calculator will set you free. Turn your calculator back on. Okay? And then what I need you to do is hit the mode button. And if you look down here, the 4th line down, the first thing should be highlighted right now. That means we're in function mode. We want to graph things in parametric mode. So I'm going to go down to there. And then scroll over and hit enter, so that now par is highlighted. She doesn't do anything in class, you know that. Okay, and when you hit y equals now, an amazing thing happens. Now instead of just having a y, you have an x and a y. Yeah, and you might have some old junk in there from other kids doing stuff. Now what we can do is we can put the parametric equation in that we started the very first thing with. It would have saved us a ton of time. Where's the T button? Yeah, the X button has magically changed into a T button. Now when I hit the X button, it comes up with the T because I'm in that mode. And then I need T squared plus 2T. Okay? Now this is kind of a weird deal. Once you get that typed in, don't hit graph yet, hit your window. When we made our little table, what was the smallest t value that we plugged in? -2. And what was the highest t value that we plugged in? +2. And what did we go by on our t's? We went by 1s, okay? So if I go t minimum -2, t maximum 2, and I go by 1s, if I hit graph now, you just see the piece that we found when we were doing this before. But doesn't it extend forever in both directions? Didn't we decide that? Okay, so if you hit your window button again, you should really have a t minimum of maybe -10. and a T maximum of positive 10. And if you want the calculator to be more fancy, instead of going by 1, since the calculator is pretty smart, you can go by 0.1 or something. And then when you look at the graph, you get that nice smooth parabola. Either one is fine. You can really screw the calculator up and make it do a lot of work if you make the t-step go by 0.00001. Whoops, that's way more zeros than I thought.
You got stuck on it.
If you hit, oh, didn't like that.
It wouldn't let me get it.
Too small. Okay, let's go
It's
0.0001. And then if you hit graph and it still doesn't work.
One more time.
Wow.
Why
this
did
is
that
like-
work?
No, I'm doing it in 001.
You can make it go by really small steps, usually. I'm not sure what's going on here. And then it takes a long time for it to have to plug in all of the little. So you got it to work.
0.01, that's like.
Yeah.
Okay, so there's a lot of different ways that you can do that. All right?
No. Well, almost done. Then I put in 1 and it took like 2 seconds. 2 seconds or